Okay, welcome everybody to the next webcast intersection on best practices. I'm Tom Beebe with Advanced Data Tools. So welcome. A couple of bits of housekeeping before we get going. For a reminder, if you are not aware, we are recording the session, so everyone's aware this is being recorded. This will be available on YouTube, usually about a week after the session happens. Also, if you have questions at any point, please use the chat box and either send them to me or to the group, and we'll be getting to question answers at the end of the session. You can also, of course, email me. I've got my email here, and it's kind of plastered all over the slide deck, so you'll have plenty of options to get it if you don't have it already. Just a little about me. I've been using Informix for about 15 years. Have a strong background in web development, DBA work, and a fair bit of Linux administration. So again, standard guidelines, please keep yourself muted. Please use the chat button. Don't try to share your screen or anything else. It should be, fairly straightforward. So about this webcast, where this actually came from. This started because we've had a number of clients to us and just individuals at the IEG conference and other places come up and ask about enterprise replication. Most everyone in the Informix world has heard about it, but I'm finding more and more people have never used it and never really explored it much because it seemed a little too intimidating, or they just never had time to get around to playing with it. So I wanted to put together an introductory webcast to a little bit about what it is, and then a very basic walkthrough of how to get started with it. Enterprise replication can be done fairly simply and with not a whole lot of effort put into it, but it is an incredibly complex and deep piece of technology. So we're just going to be scratching the surface of it today. There will probably be some follow-up webcasts on some deeper and specialized topics with it, because you can easily get going with just a little bit of ER experience, but there is a huge amount of different possibilities depending on how you want to configure it. So we're not going to get too deep into a lot of the different sections of it. We're going to just really focus on what do you need to know to get going, how to set up the server, and then the actual getting replication going. We are going to be doing comparisons between ER and HDR, because that is a common question that comes up. Which one do you want to pick? And again, we are going to just be kind of glossing over some of the more advanced features. I try to list out some of the options, but I'm not being comprehensive here. So I just want to be very upfront with that. So the agenda, we're going to talk about what ER is, explain the difference between ER and HDR. Then we're actually going to go straight into setting up the environment, getting the replication going, and then just a little bit of basic administration. So what is enterprise replication? It is log-based replication for Informix. It does asynchronous data replication, so it is not waiting for something to happen with the replication for your application to go. So it doesn't care if you have a fast connection, slow connection. It's set up so that it'll replicate when it can replicate, but it's not going to slow down your primary system or your application server or whatever the one system is that might be on a bad network connection. There's a number of ways to configure it. One of the most common is doing update anywhere. So any server you update or change or add a row, delete a row, whatever, all of the other servers linked get the same update. It can also be set up as a primary target, so you only have a single source that is available to write to. Everything else is, for the replication changes at least, read-only. If they make a change on a secondary system, it's not being pushed upstream. Enterprise replication is very efficient. It is set up to be very flexible. You can run it on multiple platforms, multiple versions of Informix. You have a version 11.1 Informix on Linux that you can replicate that to your version 12 on Solaris, to your 11.7 on HP UX, to your 11.5 on Windows, what have you. It is very flexible, very configurable. It also does allow for data repair and synchronization. It's meant to be able to be very resilient against problems, whether it's data problems, network problems, what have you. So everything is set in queues, so if there's a network problem, it'll wait to send. And if there's a problem with the replication or problem with the system, there are a number of ways to then catch yourself up, fix yourself. It's very easy to keep yourself online and everything up to speed. So you're going to talk, a number of people use HDR replication. HDR replication, if you're not familiar with it for Informix, it's when you have two generally identical systems. It's intended for disaster recovery. So you can have, disaster recovery, so you can have a direct failover system. So you have your primary and then your secondary. The secondary is an exact copy of your instance. So it doesn't matter if you make a change on the primary, the secondary will match it exactly. The same token with standard configurations, anytime anything is done on the primary, any updates done, insert, any kind of work is done on it, it will actually make sure it has been written on the secondary before the primary moves on. So you always have your secondary completely replicated with your primary. So you have that peace of mind that if your secondary is up and running, it is an exact copy. So if you need to fail over, you can immediately. I'm also going to just mention on this chart, this table, that there's an asterisk next to almost all of these. Informix is a flexible piece of the software, so there is quite a few special cases and such, but I'm going with standard cases. These will be accurate. So HDR is really good because you have the exact mirror image of your instance. You make a change on your primary, it's immediately on the secondary. You make an update on your primary, it is immediately there. You don't have to worry about it. However, the downside is, at least by default, it's set to synchronous replication. So if there's a network problem between your primary and secondary, it may slow down your primary system while it waits for the secondary to respond. It is also does not replicate byte or text fields. So if you have older blob file or blob records, they will not replicate with HDR. But HDR is easy to set up. We've had other webcasts on it before, so if you're interested, go check them out. So it's a very nice system, but it's limited. It is very, very good at what it does, though. The other thing with it is there are no schema requirements. You can use pretty much any schema setup you want, and it will allow you to replicate. Again, the exception being byte and text fields. Enterprise replication, on the other hand, is set up to do individual replicates based on what you want. This can be an individual table. It could just be select rows from the table. You can have multiple replicates that each have their own configuration, so you can replicate part or all of the database however you want to. They will replicate byte and text fields, so if you have an application with a fair amount of byte or text data, ER is really probably your best option for replication. ER is asynchronous, so again, the primary will not wait for the secondary. It'll just keep churning along, so if there's a network outage, it's not going to impact performance. It's mainly set up, at least initially, for high availability because you can have multiple points where you update data. You can spread out the load horizontally across a number of systems. It's meant to, if the primary, one system's down, it's not going to bring the whole system down. You can set up clusters that all work and the user never notices. It can be used for disaster recovery, but high availability is the primary focus. You can have a mixed environment, both in terms of Informix version and hardware. However, it can be complex to set up. HDR is basically take system A, clone it to system B, set up, and run 3 commands and you're running it. Enterprise replication, you have to consider the configuration of Informix, you have to consider the SQL host, you have to consider your schema. There's a fair amount to consider. One big downside to enterprise replication is schema changes need to be made individually, and you have to update replicates when you make changes. So if you add a new column or delete a column, you need to update the replicate to reflect that. Asterisk there is a thing called flexible grid. I'll talk about a little bit about at the end. So again, replication status, secondary one of your replicates goes down, it won't impact the primary server. One of the big schema things, and we will talk about this, is it requires primary keys or ER keys or unique indexes on every table that's being replicated. So if you don't have some kind of unique column on tables, you have to consider some alternative options. So reasons we actually want to use it. One of the big ones that isn't used as much as it really probably should be is if you only want some of your data on a target server. You have your accounting table, you have maybe your sales records. You don't necessarily need every bit of data in your entire database sent over to your remote accounting, your remote reporting server. It just needs a couple of tables. You can set it up to do that. You can also set it up so it's only a limited set of the data, so you only have this year's data replicated, or 5 columns replicated. You don't send over the huge debug file, so it reduces the amount of data you're having to replicate. Another big reason is if you want an update anywhere environment. You want to have 5 servers that tie to your application servers that are sitting there in a cluster, so if one system gets overloaded, one system goes down, the users will never notice, it just goes to the next or least busy server. I'm not going to touch on Connection Manager in this talk other than just to say it works really well with an update anywhere environment where it will actually load balance for you. Another reason to use ER again is if you have byte or text columns. I keep bringing this up because I keep having clients that they need to do replication and they find their application was written a while ago and they've done all their large objects in byte or text fields. So ER is the way to go in that case. Mixed environment, we have more and more people that are, let's say, migrating from AIX to Linux or the other way. They may have some legacy servers on one operating system running an older version of Informix, but they want some of that data going to their newer systems. There's lots of different reasons why you may have a mixed environment of systems. ER will play happily with it. Another is if you have an unstable network connection. If you've got a remote site that you've got something in the Arctic Circle, you've got 3 hours of network a day, ER will play with it. You can set up ER to work with that. You can, if you have a connection, you have somebody on a spotty DSL connection to their office, you can set it up so that it is a little more flexible around so it doesn't flood their network or only goes in off hours, or we'll just wait until the connection's back up and then immediately send. There's a number of ways to configure around that. You can set it up to have multiple targets from a single server. So you could have a configuration table that you feed out to every system in your network. There's a large number of ways that you can configure how all of the replicate paths go. And another one is spreading your data across and load across multiple instances, or otherwise known as horizontally scaling. This is one of the new big trends in big data and big analytics and everything else, where rather than having the one big system, you put everything on there, you spread it out. So rather than needing one massive system, you get a bunch of similar systems, you put them in a rack, you need more power, you just plug in another system. And with ER, what you can do is spread out that load. You can split up some of the tables, some of the databases, so that it has different parts are spread onto different servers and actually either load balance or even split the querying across multiple. They've added a feature called sharding that is a separate advanced topic, but you can actually spread your queries across multiple servers using ER. So we've decided we want to use ER. The next thing is what kind of replication. The big one is Are we doing update anywhere so that any server can update any of the rows that are being replicated and all the other systems see it? Or are we doing primary target? I have examples of both, but the only real difference is the primary target means that any of the target servers, and there can be more than one, if there are changes to the data, it will not be pushed upstream. So the users will only see the data the data changes that are on the primary server. Unlike HDR, which the secondary is generally read-only as a database, enterprise replication tables, they're still read-write. You can still update data, you can still delete data, whatever you need to do, just the changes will not be replicated. So a little bit about terminology, just so when I'm using them, we're all on the same page. An ER domain is just the entire cluster of ER nodes. Every system's generally only on a single domain. So this is a list of basically every server, connection, et cetera, inside of a cluster. A node is a particular server. There's a number of different node types. A replicate is a table or a set of columns that are being replicated. So it could be just the stores, the stock table, which is we'll actually do in a few minutes from the stores demo database. That could be a replicate, or it might just be customer first name. It could be a set, it could be where it's a year 2017, whatever, but it is whatever an individual set that is being replicated. On the other hand, there's a replicate set, which is a group of replicates. That was introduced to be able to do commands on a series of replicates at once. So you could have a replicate set of your whole database and be able to do your ER commands to manage those replicates all with one command rather than needing to have a separate command for each replicate. Then there's ATS and RIS, aborted transaction spooling and row information spooling. What these are is if a replicate fails, or if a transaction fails as part of a replicate. Common example I've seen of this is if you have a delete, somebody of a primary target system, somebody's gone on the target system, deleted a row, and then on the primary system, somebody issues a similar delete. But when it gets to that target system, the row is already deleted. It'll view that as a failure because it can't delete a row that does not exist. Number of possibilities that may be in there, but anytime that there is a failure, it'll generate, if it's a transaction, it'll generate an ATS file and then an RIS file, which is the actual row information itself. So you can go in and actually look at what failed. It'll tell you why it failed, and then there are ways to then repair it if you need to, or you may just say that this is an acceptable failure, this is expected, and move on. But the files are there. So with the ER nodes, there's 3 types, and this is something to consider when you're setting up your network. If you're doing a simple one-to-one replication, you have your primary server and your target server, or you have 2 servers, update anywhere, you don't really need to think about this. In our example, we're doing 3 servers. They're all going to be root nodes. Root node is the standard. They'll connect to every other server. They'll know every replicate that happens on the domain. They will be expecting that they can replicate with every other root node and every non-root node on the network. So you have to be able to allow it to connect to all of the other systems. Most domains have either one or a small group of root nodes that are all physically located nearby. And then off of them, you have non-root nodes. These are also nodes that know all of the other servers. They have the full catalog of replication information. They have all the other information there, but they're not expecting to talk to all of the other systems. They're kind of the middlemen. And then finally, we have the leaf nodes, which these only talk to a non-root node or a single root node. They can't talk to other leaf nodes. They don't talk to multiple servers. It's a purely, this is your end result server. So if you have systems all over the country, you might have a central non-root node in Atlanta, but then Jacksonville and some smaller towns in Atlanta may have their own leaf nodes that only need part of the replicate set. They don't need the full thing. They just need a small replicate chain. If you're dealing with two systems, you don't really have to think about this. Root nodes will be fine. Just for another example, we might have root nodes in Chicago, New York, and DC, all of which are on fast networks, all of which talk to each other. So all three of them have the complete replicate information in them. But then they have a series of non-root nodes that are physically close to them, so that'll be where the data flows. And then some of those, like Providence, Rhode Island, might be a leaf node off of Boston, because that's just how the networks are set up. So, the data would be replicated from New York out to Boston, and then from Boston out to Providence. So you can actually define a map of how the data is flowing, so you can set one or more paths of data, so you have the fewest hops physically between systems. If you've got a global environment, or even a fairly widespread geographical environment of your servers, this can really come into play for how you plan out your system. There's far more to this than I'm going into in terms of the planning stage, but I wanted to bring it up because it is a term that we will be using. The next term that is important to consider when you're planning your environment is conflict resolution. Again, if you're doing a one-to-one replicate, you probably don't have to think much about this, because you're probably not going to run into conflicts. But if you're dealing with a fairly widespread environment, this may happen. You may have your Providence, Rhode Island replicate, does some update. At the same time, your New York one does an update against the same row. Both of them hit Chicago at the same time. Which one wins? If they, one updates the amount to $10, one updates the amount to $15, which one wins? This is how you define that. And there's a number of ways to do it. The first one is you always apply. So it doesn't matter, just whichever one hits last is what that value is going to be. The second one is ignore, which you just don't resolve conflict. They work fairly similarly in spread out environments, but you can do that, and it just doesn't bother with conflict resolution. With the always, by the way, I do want to add in, if you're doing a primary target, you generally always want always or ignore. Those are the only two options for it, because it is always going to be coming down from a central source. The next one is timestamp, which will actually look at the timestamp of when the update happened. This is where having synchronized clocks are important, but what will happen is if it sees that the Providence one was 2 minutes before the Rhode Island or the New York update, it'll view the New York one as probably newer and then takes precedence. Delete wins works with timestamp. However, if it's a delete request and then an update request on the same row, it views the delete as winning and just ignore the update. You can also set up a store procedure. There's all kinds of logic out there if you want to build a custom store procedure to actually manage your conflict resolution. If you have a very complex environment, you might need to. They put it in there, and also the timestamp with store procedure. So again, most situations, it'll either be always or timestamp. It depends on your environment, but it depends on your environment, and you may have special cases. So, going to actually get into the setup now. That's just a little bit about ER, a little bit about the basic thoughts of what you have to plan out for when you're setting up your enterprise replication environment. Normally, most people start out with a couple of servers pointing to one central one, or just an update anywhere environment. If you're dealing with 3 or 4 servers, you probably don't have to plan too much, but if you're planning to grow into the hundreds, you do. Obviously, probably, you should be considering all sorts of ramifications if you're looking at a large enterprise replication rollout. So to actually get into how we set this up now. So you've planned out, you kind of know the paths you want things to go, you kind of know what you want to replicate and how you want that data to flow. Great. Now we need to set up Informix to be able to handle it. The first thing is we have to set up an SB space to hold the send and receive queues. How ER works is when a transaction happens of any insert, update, delete, UDR. There's a few other types that do it as well. Store procedure call that doesn't update, etc. It actually writes out the transaction information into a queue that is written in the ER SB space you've created. So it'll sit there in the send queue. It sends it over to the target server, which gets it in the receive queue, and then as soon as it can, it applies. I'm simplifying this a fair bit, but that is the basics of it. The trick with this is the SB space needs to be able to hold enough data to be able to run with this. If you have a tiny SB space, you have a whole lot of traffic. If that SB space, smart blob space fills up, it's going to hold up. It's actually going to stop replicating until it empties out, and you're going to lose transactions from that path. So you need to make sure you size it correctly. The second thing we have to do, so we've got our smart blob space, then we have to create a standard DB space. This is for the transaction records. This is the headers of the transactions, and by default, this will go into root DBS, which you don't want, because if you get a lot of transactions that are backlogged, you could actually have your root DBS fill up, which you don't want to have happen. The third one is define DB space for the syscdr database. This is a system-level database that'll actually control or manage all of your replication information on your root systems, especially if you have a complex environment. This may get fairly large, so you want to plan accordingly. So you need to create those 3 DB spaces on every system you're going to be running enterprise replication on, not just the root nodes. The sizing does not need to be identical. You may know that one of your systems is going to be much more active, have more replicates. That one probably is going to need larger sizes than the one system you have a single replicate to. So once you've created those, we need to go through and actually set up the network connections and verify that all servers can talk to each other. Then we're going to make sure that there are sufficient logs on all of the systems. If you've not run replication before, it does use a fair amount of logical logs, so you want to make sure you have plenty to find. Set up your SQL host file. That's part of the verifying connections. And as part of that, we need to have Informix set to use the DB server name of a TCP connection. A number of people, because it's often set by default, set up the shared memory Informix connection as the DB server name, and then the TCP connection as the DB server alias. This can be as simple as just swapping them, so your TCP connection is your DB server name, but I mentioned it there. Also make sure to update any profile files to make sure it uses the TCP connection. Depending on the Informix version, there can be some weird, it won't actually create the replication if you're running on shared memory connections. And then finally, we need to actually make directories for ATS and RIS, and typo there, we'll fix that before we send this out, RIS directories. So we just need a place to form somewhere on the system for those files to go. If we don't build them by default, they go into /temp, where we probably don't want them sitting there. They can actually have SQL information in the files, so we don't want those, world accessible. So we've done that. Then we're going to go through and do ONCONFIG changes. So these are the 3, we need to define in the ONCONFIG the 3 DB spaces we've created. CDR DB space is where your syscdr will be created. So we definitely want to have that not be in root DBS. The next one is CDR QHDR DB space. So this is where the record headers will be stored. It is 110 bytes per record. So you can do the math for how many records you expect to have in, I normally see a 72-hour window, and give yourself another 25% of space. That is a back of the napkin estimate for it. Feel free to make it larger than that. I normally say 72 hours for sizing, and I know some of the Informix guides actually say 24 hours, but I like to use 72 hours because if you have a long weekend, everyone's on break, like the holiday season's coming up, this may well happen in your environment. Um, if on Friday afternoon the network goes down, something happens, so replicates stop getting sent across the wire and they start backing up, you want to make sure you can get well into Monday before you're going to have things fill up. This goes for your record header database, your smart blob space that has the actual data information in it of the transactions, and your logical logs. You want at least 72 hours, and your environment, if you know that there are periods where it's longer than that, you want to make sure for the longest period as possible, you are not getting paged while you're on vacation. That's kind of how you want to size this. Feel free to make it larger than you think you need because you may have that sudden rush, your business may grow, and you may not want to have to go in and add more chunks to every ER system you have down the road. The CDR QData smart blob space, so again, this is where the spooled transaction will be housed. You know your data, you know how big the data may be, so you can kind of estimate how much would the potential data be that would be stored in a 72-hour window if we have to basically spool every transaction that we have coming in for that period to send it out. You can, by the way, have more than one defined, and it'll go through them. So if you need to have your primary and then a failover, that's fine. So we've got our spaces set. We've updated ONCONFIG. The next thing is setting up trusted connections. If you've worked with HDR before, it is the same, or just any kind of trusted connection system with Informix. It's the same principle here. You need to use host equiv, rhost, or remote server config if you're running version 12. I think it was added in late 11.7, but it's just an alternative version of rhost. And all you do is add the server name and followed by the user that you wish for it to connect to. Normally with CDR, people use Informix, but it all depends on your environment if you're using Informix or not. If you do not have a trusted network, you can't trust your DNS, you can't trust whatever, you can use OnPassword to actually go and set up a trusted password file to use to authenticate instead. I'm not going to cover that in this talk, but I just wanted to mention it in case anyone is in that environment. So set up the rhost file. The rhost, by the way, if you have not worked with it, you just put a file in the Informix home directory called .rhost, and just make sure it is not world writable. That's all you have to do. It's just a plain file. You do not have to reboot the engine between. It'll pick up the rhost if changes anytime that someone connects. So next thing is to adjust SQL hosts. The first thing is all ER connections need to be part of a group. If you've not worked with groups in Informix before, this is what the syntax looks like. You go to the group name, the second, and this in this SQL host file. So first column is group name, second column is just the word group, third and fourth are just dashes, and then fourth is I equals, and then a number. And that number is between 1 and 32,000. It is a unique identifier for the group. That has to be unique per SQL host file, otherwise the engine will get confused because it does a lot of the connections based on that group ID. Then the second line and what you need to modify is standard SQL host entry, so the listener name, the protocol to use, the server to connect to, or service interface to connect to, the port number, and then you add a fifth column, which is G equals, and then the group name. So what we're telling it is the system TCP connection is part of the ER group. So part of ER does expect every connection to be part of a group. What I normally make is a master SQL host file for small to moderate size networks at least, of every connection in every group so they're all consistent, and just push out that file through any number of standardized means. So everybody has the same SQL host file and you don't have to worry about something being missing. Again, make sure the DB server name is your TCP connection, and every server that is going to replicate with each other needs to be in the SQL host file, in every SQL host file. And every root server needs to have all of the hosts, at least the root and non-root servers, in their SQL host file. Otherwise, you get a bunch of errors in the online log where it can't reach those systems. So a sample, and this is actually the one I'm going to be using today, is I've got 3 servers set up. I'm calling them Chicago, New York, and DC. So the groups I'm calling Chicago, G_Chicago, G_New York, G_DC. I intentionally am keeping this simple, trying to keep it straightforward. Obviously, production environment probably will be more complex. So a little more on trusted hosts, just so I had a slide on it here. You just take the Informix home directory or any user account you're connecting as. I'm using Informix as a default here. Add host name and then the user to connect as. So some systems will come in as the short name, some will come in as a fully qualified domain name. You have to see how it's going to resolve it. What I always do is once I set up the trusted host is I use DB access, go to connect, and make sure I can connect to the remote server. I should be able to see the database I'm expecting, and I should be able to do the same the other direction. If you get the error, incorrect password or user is not known to the database server, the @ and then the server name is what it is coming in as. So you can see if it's coming in as the fully qualified name, the short name. I had one client where it started just coming back with the IPv6 address. It just depends on your environment, how the reverse DNS lookup happens. So we've got Informix now set. You can go ahead and restart the engine, get it up with the new group set up, make sure it's the DB server name is set to your TCP connection. You're picking up the changes to the CDR ONCONFIG parameters to make sure you've got your new spaces in place. Should be ready to go at this point to replicate from Informix standpoint. The next part is setting up our data. The first thing we have to do is identify the tables we wish to replicate. And the big thing that they need is every table that is being replicated with ER needs to have a unique identifier. If you're running version prior to 11, it has to be a primary key. In version 11, you can actually use ER keys. I have the example here at the bottom, alter table, then the table name, add ER key. What this does is adds a shadow column at the end, or actually 2 of them at the end of the table. So you won't see them if you do a select star. You can get in through this through some of the system tables to view the columns, but we'll tack them onto the end of the rows for every row and basically give you a unique key for the system. I prefer to use a primary key just because it tends to be a little easier to manage, but it all depends on your environment. If you're running a table that doesn't have a unique field in it, then you generally need to add in an ER key. In version 10, they added a new flag -key, and you can actually use an existing unique index in place of a primary key. If you're going to be using timestamp conflict resolution, just one other note here, you need to add the add CR calls. So this will actually add a timestamp shadow column to the table, so you can actually then use timestamp-based conflict resolution. And lastly, and this is optional, but I recommend it, especially if you're already adding shadow columns, if you add REPL check columns, so same syntax as below, it'll actually add in a special checksum column. So it'll make if you're doing a check between a primary and secondary server, it'll actually make it much quicker to compare the tables to make sure all the rows match up. So we set up our data, we go on, we create the primary keys or make sure they're there, and that needs to be on every system. The primary key does need to match up, otherwise it will not work. So we now are going to go through, and I'm actually going to go demonstrate this in just a moment, but I'm going to go through the slide versions first. The first thing we're going to do is set up the primary, the first node on our domain. The syntax for this is CDR defined server. Optional, but I add optional, as you really should always have it, unless you have a really good reason not to, is have the -A for your ATS directory and the -R for the RIS directory. If you don't define them, it goes into /temp if you enable those, so I really don't recommend running servers without it. Then you pass a -I and then the group name. And what you're doing there is you're telling it, I'm going to initialize the server, so I'm starting it up, and this is the server name I'm going for. So I'm initializing myself, and what it does when it initializes is it actually builds the syscdr database. So if you create it, when you initialize, it creates the syscdr database. If you delete enterprise replication, if you delete the server from itself, it'll actually drop the syscdr database at that point because it's dropping off of the domain. So we've got our first node up. We do the second node, which is very similar syntax. This time we're doing the -I and then the second node, which is our group New York. And then we pass in a $S, and we're actually going to give it the master server or one of the root nodes. What we're telling it there is, I want to join the domain of this server. So I'm initializing New York, and I'm joining the domain that group Chicago is in. And at this point, it will go in and actually build syscdr on the New York server. So I've done this. I've actually added a third system for group DC, and I do a CDR List Server, and I can see all of the systems. So nothing up my sleeve. I am going to go ahead and actually do this. So I've got Chicago as my primary system. I went ahead and created shell scripts so I could share them afterwards. So these will be available alongside the slides once we are done with the, once we post all the information after the presentation. And what I have is a simple script, create Chicago. Nothing, it's the exact same stuff I had in the slide there. So I'm going to go ahead and run that. And so nothing up my sleeve. So CDR List Server, try to connect. It's showing the enterprise replication is not active. So I'm going to go ahead and create Chicago. So it is doing CDR defined server. And now if I do CDR List Server, I will see myself. And I'm going to go over to New York and add New York in. And New York, I have the same thing. I predefined it here. My mouse was not working for a moment there. So same thing where I'm adding it to the G Chicago domain. So if I do CDR List Server, I see both of them. I see it connected. I see the last time that there was a connection change of any kind. I've got the information here, and I see that there's nothing in the queue. If I run DB access, I will now also see there's the syscdr database. So everything is created. So that's all there is to actually getting the servers up and running. I do have, just to show in advance, let me extend that window a little bit here. I did create the SB spaces needed, the ER one. So everything is created that I need to for replication. It's that time of year again. So we now have our servers communicating. Actually, let me go ahead and add DC in. Just gotta have that in my samples. So I can see all three servers now. So actually create a replicate. It's a little bit of a longer syntax, and there's a number of ways to do this. I'm showing the fairly straightforward way for this sample. Is we use the command CDR define REPL. Then we pass some flags to it. The first one is -C. So this is actually, oh, and I have a typo there, but extra T. -C actually tells it what server to connect to. The nice thing is that you can actually, with Informix with CDR, which is CDR is the control center for enterprise replication. It's basically the binary file that lets you do a lot of the commands against it. I don't want to dig too deeply into it because that's a talk unto itself. But with most every CDR command, you can pass the -C, which will tell it what server to run on. So you don't necessarily have to be connected or even have shell access to some of the remote servers or some of the servers you want to run things on. You can just do CDR and pass the -C, and it will run it for you. Then there is the $C, which is the conflict resolution rule. In our case, we're doing a two-part replicate. I just have two systems that are running it. I'm just going to tell it to always. The third thing I'm passing here is the actual replicate name. This needs to be unique for the domain. So depending on how many tables, how many systems you're replicating, figure out a good naming scheme. You do want that to be consistent. The next thing we pass is, in quotes, the table itself to be replicated. So in our case, it's stores demo database at the G_Chicago group, and we're telling it the Informix own customer table. And then following that is the SQL we're using to access that table. In our case, we're selecting star from. And then the next part is our other target. So our second target for this is going to be stores demo G_New York Informix own customer table. Again, select star from customer. So we're telling it from Chicago, we're looking at the customer table, we're selecting everything from it. New York customer table, selecting everything from it. The select star is good and bad in this case. If you have tables that are going to remain the same, select star is fine. But if the tables are going to change schema, or if the tables potentially do not have the same schema, which does involve the order of columns. You know, some tables have this column A before column B, and then other tables have column B first and then column A. You know, select star will actually give an error on that when you try to initialize or create the replicate. And if you change the table down the row, it's not going to work with the replication. You'll just get an error. So you'll have to basically delete the replicate and recreate it. If you think the table is going to change, actually spell out the columns. So select column A, column B, column C, comma separated, just like you would from any SQL statement. All depending. Again, I'm keeping this straightforward and simple, so we're doing select star from, and I'm doing this all against the stores demo database, so everyone has a copy of it. So a couple of other notes. Actually, the only other difference one is you do not necessarily need to have the same table name or database name between the systems. You can have it be an entirely different setup as long as the columns match up. That does involve also the column length. So if you have a varchar 10 and a varchar 20, you'll get an error trying to define the replicate. So when you actually run it, you'll get this, where it actually goes through. The first thing it does is creates it and then verifies it on both sides. If any of the steps fail, it'll delete the replicate and return back a relevant error. Then there's a command, CDR List REPL. So this will actually, and you can pass the replicate name, will actually show you the replicate. So we've created the replicate, and this is the output from Chicago, where we see that the conflict is always apply. We see the participant. You know, we can go through, look at the REPL mode, the REPL type. We're doing update anywhere. The REPL type will generally be master. Number of different ways to tune all of this. Queue size is how big the queue is currently, so you can get an idea from there. Notice though under state that it shows inactive. The reason being is that you created the replicate, we haven't started it yet. So, and again, this is what the replicate looks like on the other side. Again, you pass the -C and you can tell it where to run the command. Only difference here is just the showing it's connecting on our G and Y rather than G Chicago. So to start it, all we have to do is do CDR start REPL and then the REPL name. I've got that in the sample. And I'm going to go ahead and create the replicate. So I've got a script here for define customer. Oops. So I have defined REPL here, Chicago, and this is the same that's in the sample. And we see the verification. So if we do a CDR list REPL now, we'll see it there. It's sitting there as inactive. So if we do CDR start REPL customer, because REPL customer is the name of the replicate, and again, it's doing the customer table of stores demo. So now we see it as active. So that's the big key you want to look for. If it's inactive, it's not going to track any replication. At this point, I've already synchronized the tables. They are already the same before going into this. It will not automatically update all the rows over. It's not going to synchronize until you tell it to, and I have a slide a little further down about how you do that. So we've got this replicate created between two places, and what we have is I created a real simple SQL add customer. So very simple adding to it. This is my nothing up my sleeve kind of demo. So I'm going to pull that up. I have not run it yet. I'm going to pull up New York. Oops, customer number. Oh, customer number. Okay, nothing is currently found. So over here on Chicago, I'm going to go ahead and run this. Creates the record. Then New York, I'm going to run this. I'm running it right now. And now it pops up. See, it took a couple of seconds there. There are ways to tune it for speed. By default, it will wait through a couple of buffers before it gets sent over. So it is not an instant apply like it is with HDR, but it will get there and it goes through the queue in the process. But this is a very simple example of a enterprise replication replicate. So next up is a little more complex. Is you can set it up to have multiple targets. Rather than just doing a one-to-one, in this case, we're doing a three-way replicate. So there's going to be an update anywhere across 3 different servers, so New York, DC, and Chicago. So I'm going to go ahead and I think it's lost my space on there, and create this. I've already prepped it in advance. So define stock just creates it against the stock table from stores demo. And see, now it actually does the verification on all 3 servers. We've got it created on all 3 of the places. And what I can do is go over to DC here. And what I have a small script that's going to create a few records starting in stock ID or stock num 10,000. So nothing is there so far. I'm going to go ahead and add it in over here. So insert those 2 rows, go over to DC, and they pop up. And the same token on the DC side, I created a small one to add 10,002, 10,003 over here. Added those in, and now they're being replicated from the DC side. And again, they haven't popped up yet. There we go. And now it's being replicated across, all three instances now have the exact same table. So we've created that now. That was all it took to then create a multi-target, replicate. Okay, I'm not going to kick it back to the beginning here. There we go. So CDR List REPL, just for reference, it's there. And this is actually, there is another CDR command that I just mentioned here for reference, is CDR view send queue, which shows you what the send queue is like. I was able to capture it when it was sending that over when I was testing it earlier. And that's actually what it looks like. I had the transaction memory. It hadn't been sent out yet. And so it's sitting there, and you can see, the amount of data used, which isn't a whole lot. So now we've created a couple of replicates. I'm going to change one of them up. So I'm going to go ahead and actually delete the replicate we just created. Because it is a three-way replicate, I can delete it from any of the sites. So CDR, delete REPL. You'll notice consistent naming on these. So REPL stock is no longer there. So I've got an alternate one here to actually create the REPL stock, which is define stock PT. And what we have here is the same kind of syntax, but you notice at the beginning here, there's a P and an R. The P is for primary, R is for replicate. And what this is going to do is this is going to make the Chicago instance the master, the primary. And then every other instance be a target. So what it's going to do is any updates on Chicago will get sent out to all of the other systems. But if there are changes on New York and DC, they're not going to be sent up the chain. So I'm going to go ahead and add this. So again, it creates it. And the one big difference here is if we can do CDR List REPL. I call it the same thing, REPL stock. It looks the same on Chicago. But if I run this against New York, so I'm using the -C New York, you actually notice over here in REPL mode, it is now showing read-only, because this particular one is going to be a read-only replicate. It's active, we're good to go. And what I'm going to do is actually delete the records we added a minute ago. So those 4 were deleted. And what we should see in DC no rows found. So what I have is I've got that file on DC, the add extra stock. So I'm going to run that on DC. So adds those 2 rows. They're here on DC. However, again, if I go back over to Chicago, because this was a read-only effective database, nothing's going to be replicated because it's not going that direction. So depending on your environment, this may or may not be relevant, but I wanted to mention it because it's a commonly useful feature. So again, this is just the same output we saw where it's showing read-only. So now we've got replicates. We're replicating data. ER is now working. We have it up and running. This has taken about an hour. Obviously it will be different depending on your environment on how much planning you have to do. So we've got it, and now the replication has been running a while, and we had a problem on New York. It was down for a week. So we need to find out where it left off. There's a problem with the replicate. There was a problem with network. Somebody deleted some of the rows off of New York, and it was a read-only target. There are any number of things that may have happened so that New York is not in sync with everything else. So they added a feature called CDR check replicate. This will actually allow you to check the status of a replicate set. So master is the primary server. This is what we are considering this is the system that has the authoritative source. REPL is going to be the replicate we want to check. And then the extra arguments are any servers we wish to check. This can take a while on large servers, especially if you have like binary data or JSON data or something like that, and you haven't added the REPL calls, shadow column. Reason being is it actually goes through and does a checksum of the row itself for every row, and then compares them. So again, if it's a large table, that can take a while to process. And it will use a fair amount of logs during the process down the road, or down the process, especially if you're doing a repair, which I'll talk about in a moment. And so it runs and it comes back with, us here. So we're seeing the number of rows, if any are missing, mismatched, et cetera. So this will actually go through and validate your data for you. There's an added feature here, which is the repair option. So -- repair does it. And what it does is the same logic as the check, but will actually go through any rows that it views as incorrect, missing, additional, et cetera, and repair them off of the master system. So you can treat one system as your master, all the others as targets, and it'll make sure everybody's up to speed. You can use the -all to actually say all servers on the replicate set, or you can actually list out if you only want to check one system. But I will tell you from experience, if you have large rows, you don't have REPL calls in place, it will use a fair amount of logical logs. So a couple of flags here, I put this for reference. You can background the process and then check it later on. If you do that, make sure to add --name so you actually name the job. Otherwise, it can be hard or even impossible to retrieve the data on the status of it. You can set it up to extra target rows. There's a number of flags there where you can actually set up what happens if the target system has rows that the primary doesn't. In some cases, you may have archival rows you don't want to delete. Other times, they may be rows that should have been deleted but weren't. Every place, this is where, as a DBA, you figure out what's right for me. You can tell it with fire trigger what to do with triggers on the target systems. One here that is, if you're dealing with large objects, skip lob. That means for the checksum, it will not do that on the byte, text, blob, or clob fields. So it will use far less resources trying to do the checksums. This can be a huge time saver. You can also set a timestamp. If you have the timestamp, if you've actually set the CR calls on the table, so you have the timestamp ability, you can actually say timestamp. So I only want to repair the last week of data. I only want to repair the last month of data. Entirely dependent on if this is useful or not. Same token, you can use a where clause. So you can actually say only where the ID is greater than 1 million, only where the date, the date added field is greater than, Tuesday the 4th, whatever it might be. It's there, it works. They're very nice features to try to tune the speed of this if you're dealing with large data sets. There's also a CDR sync. This is good for populating data that is not on the targets. This is less of checking data, and this is more of moving rows that are not there. So just mention that it is there. It does not use, it bypasses the logical logs and just tries to send the data directly. So it's good if you're populating a table for the first time. I will warn, if you have a huge table, I would do it through another method, any number of the Informix data transfer options. This is not necessarily the fastest way to move data. So a few other notes about ER. OAT has a specific plugin for ER, so if you're using OAT, you can actually do a fair amount of your ER work inside of it, and it does some really nice graphing for you. In version 11, they introduced, and especially in 11.5 and 11.7, they introduced all of the sysadmin functions, and they've added almost all of the CDR commands, and most of the enterprise replication tasks can be run through the sysadmin SQL API. So that can make it really nice if you're dealing with a large environment to actually build SQL that will help you with the administration. ER can be set up using SSL connections. Outside of the scope of this talk on how to go through that, but you can do it. There's an extensive set of monitoring, both in the OnStat G. There's a number of OnStat Gs, but CDR and RQM are two common ones. But there's also a fair amount of monitoring using the CDR command. That just, again, outside the scope of this talk. CDR error will actually show you any replicating errors. That can be useful if you're debugging a problem. CDR, or enterprise replication, supports templates, so you can actually set up a template for particular tables or for a full database. It makes it much faster when deploying ER against a large number of systems. REPL sets can be created. I mentioned this earlier, where you can create a REPL set against a series of replicates and do things like your CDR check, your repair, your sync against a whole REPL set worth, rather than needing to do them one at a time. This can be really useful for administration if once a week you do a check REPL job, and you can just do it against a full set of REPLs rather than needing to have each one spelled out. You can set replicates as well as the full ER system to stop, and you can also pause it if you need to. So those options are there if you need to do some work or you have something going on you don't want to replicate. In version 11, ER Grid was introduced, which gives you a number of options if you enable Grid and set it up. I'm not going to go into a full Grid talk here, but it allows you to do things like actually roll out schema changes across a full set of replicates at once, run commands against a full set. There's all kinds of nice features with it. If you're dealing with a large spread out ER environment, I would highly recommend looking into enabling Grid against it. Something I have found with one of my clients, if you're running version prior to 11, especially if you're running 9 or 10, and you're replicating against an 11 environment, there's a number of cases where, especially if the network is not stable, where you may be getting invalid rows or invalid replications happening, and it can become a constant source of needing to do check REPL. I really recommend, if moving to 11 is a possibility, going that route. But if you're still running 10, just be aware that they have done a lot, especially in version 11, but every iteration since then, to make ER faster, more stable. They have all kinds of bug fixes that they have put in, and it is worth it to upgrade if that's a possibility. One other ER thing I'd like to mention, because this has come up for a number of people I've talked to, is you can set up ER to schedule when it sends or when it actually does replication. So either you can do it by starting and stopping the replicate, or actually there is a flag you can actually set up to tell it to replicate at specific times. This can be really useful if you have a very remote system that only has internet for a few hours a day, or you only want it to run during non-business hours or things like that. It allows you to do that. It's a very nice feature. Just with everything else, you need to make sure that your queues can handle spooling up that many transactions. And one other thing I wanted to bring on here, I went back to some notes on what different versions introduced with Enterprise Replication, just for point of reference, because I know people in the Informix world run a wide variety of versions, so just looking back on it. ER was introduced in 7.2.2. 9.3, they introduced UDTs and parallel applies. 9.4, they added large transactions, which had been a problem previously, and also allowed the ability for HDR and ER to play nicely together, and they do. 10, they introduced templates and the sync check feature. 11, truncate, they added the ability for CDR to actually make ONCONFIG changes, and they put in a whole lot of bug fixes. 11.5 and 11.7 did flexible grid. Oh, I forgot a typo there. Cloning ER with IFX clone. I will get these typos fixed before this gets sent out. Cloning ER with IFX clone, added in the ER key feature. So again, if the ER key feature will work in lieu of having a primary key. 12.1, they added time series support, sharding. They removed the primary key requirement, but you still need either ER key or a unique index in place. So they continue to iterate on the system. They continue to make it faster. They've done a lot of performance enhancements under the covers. So just there's a lot that's been going on. So depending on where you're at in the Informix version, cycle, just to give you some ideas for what you have available to you. So links, and I know it's a little dark or light on this. IBM has a pretty good paper on setting up ER for the first time. I spell things out a little bit differently, but it's a lot of the same data or same information if you want to look at it. There's a really neat article on DeveloperWorks about actually using some graphing tools to diagram out your ER network. Nagaraju did a fantastic presentation for us at the WAG a few months ago about ER. Actually got a lot of the changes by versions from him on that. Goes into a fair amount more depth on different topics on it, but if you're interested, I highly recommend checking it out. We've got the presentation link there off the WAG server. And I just linked the IBM document listing all of the CDR parameters for ONCONFIG. There's a large number in different things you can do to tune it. I just really focused on the 3 DB spaces because those are the ones you just need to have to get going. So going to go into questions here. Let me pull up. Okay, we do have chat. Hold on just a moment. The question was, if you guess the size of the syscdr or QHDR DB spaces wrong, can you add additional chunks, or does it have to be contiguous? You can add additional chunks. You do need to, I have seen with at least the SB spaces, you have to, I have seen the queues, and this was actually on a 10 system where it didn't pick up the additional chunk for the send queue until I bounced the engine. I honestly don't know if you would have to bounce the engine for the QHDR database or the syscdr. I think they should just grow into them, but you don't want to run out of space completely because then you are going to be losing data. And I think if syscdr fills, I think it'll actually basically put a hold on replication. So, I mean, you have to, syscdr is not going to be huge unless you have a massive amount of replicates. The headers for the QHDR can get kind of big, but it just depends on how many transactions you have backlogged. So that's just where if you need to add a space, you add the space, and I think it'll pick up the QHDR. If I find out anything differently, I will let you know. Does anyone have any other questions? Okay, great. So feel free to email me if you have any follow-up questions. Again, I'm going to fix those couple of typos I missed and get this out. Oh, one other question. Okay, so what happens if you're running HDR and ER for a few tables? Does the ER replicate? Will it run in a failover? What will actually happen in a failover, and this is, I haven't tried this on 10, but on 11 I've seen it work, where it'll actually migrate when you go from HDR primary and then move over to the HDR secondary that promotes, your ER replicates will actually move with it. So it should be actually fairly seamless. Again, you have to make sure that your ER system can be able to reach your secondary server, but you can have it basically fail over the ER replicates. So, and I think I mentioned it, but just so it's clear, you absolutely can run ER and HDR in conjunction. One of the really good ways to do a very robust backup is use ER to replicate a server where it may not be necessarily real time, but out to a remote site, and then actually do an HDR set, basically replicate that remote server with HDR, so then you always have then a backup server to that one. There's lots of different ways to configure it, or you could use the backup server to do things like report running where it just needs read-only access. Any other questions? Okay, great. So again, feel free to email me if you think of other questions, have problems, want to tell me the really cool thing you've done with this. I'd love to hear, how people use the technology. Also, I'm just going to throw out there, if there are particular topics you'd be interested in us going into more depth on a future webcast with ER, let us know. We are, we generally come up with the ideas, but if there are particular topics that there's a lot of people that are interested in, we'll try to look at those. So next webcast, 2018. We do not have we are working on finalizing our schedule. Should be out hopefully in the next few weeks, at least the first few webcasts. So stay tuned to the website for that. As always, we put them up on Facebook as soon as we have them, and they'll go out through the WAG mailing list and everything else. I don't have a slide because I wasn't able to finalize the date yet. We will be having a next WAG meeting for those of you that are members of the Washington Area Informix User Group, somewhere early 2018 in Maryland. We are just finalizing location right now. We've got training coming up. We have the Advanced Informix Performance Tuning, February 5th through the 8th. And then we have the Informix for Database Administrators, April 23rd through the 26th. Standard policy, we do not cancel a class if we have even one student that has registered. So we have had the last several courses fill up, so register early if you're interested. More information on the website. We did just, if you've been to our classes in the past, we did just upgrade all of our training servers, got brand new ones. Everyone's now 16 core, 16 gig of RAM. It's brand new actual servers for everybody. We had to actually, Lester went through and rebuilt a lot of the class samples to actually make them run quite a bit longer because the servers are so much faster to get them to where they were before. So they're better, more disks, so should be, the last couple of classes on these have been excellent, so we're looking forward to the next few. As always, our offerings for remote DBA support, Informix tuning, training, consulting, etc. More information on the website. Feel free to reach out to us. We're pretty easy to get a hold of. Again, thank you. If you have any questions, comments, follow-up information, want to tell me again about cool things you're doing, drop me an email. And thank you very much for being on. And have a nice one. Happy holidays if you're not watching this on replay. And if you're on replay, glad you listened to it.